All right, so we're going to continue from where we left off last week with this exercise that we're going to break a password basically. So just to review, first of all, remember that we are online. If you're online, you can ask questions on Piazza. We've got a live Q&A thread going for that. But anyway, to review what we're about to do here is that a password security part of passwords is that passwords aren't, or they shouldn't be at least, stored directly on a server. If you ever have a password recovery service that sends you the password, you know that they're doing it wrong because they can never, that should not even be possible. That they should never be storing the password on their servers, in their database or whatever. They should be storing hashes of their password. And here's an example. It's just an online SHA. SHA-1 is a cryptographic hash function. MD5 is another one. MD5 has been long since been broken. SHA-1 is no longer recommended for password hashing. In fact, no blind hash function is recommended for password hashing. Instead, you want to use a password-based key derivation function where the point of it is to slow an attacker down, so that even if they have to brute force your password, you want them to expend as much computational time as you can, right? So this is one area where we want things to be inefficient because we want them to be, we want to slow hackers down. But you can see here, if I put in a common password like password, or I put in password 2019 before, and I hash it, there's the hash value. That's what would actually be stored, or something similar to this would be stored on a website's database. And so next time you come in, you provide your password, and they don't store the password, they hash it, and then they check, is the hash the same? And if the hash is the same, then access granted. And it should be from just the hash. It's not an invertible function, so you can never go back to the original because it's not a one-to-one function. And so that's the scenario here. But you can brute force it by simply guessing. I'll guess this password. Does the hash map match? If so, then okay, well then this password is just as good as whatever password they were actually using. So here's my password. There's the exact same hash value right as right there. And of course you can see, I found this really quick article here about you can actually download entire rainbow tables of broken, pwned passwords. 306 million freely downloadable pwned passwords, all derived by SHA-1 from various different websites. You can download these and you look up the hash. If you steal somebody's hash password, you can see is their password one of these 306 million that have been used on actual websites. Here is my hash password that we need to break today in this exercise. And I'll just give you a hint here that it was a dictionary word appended with a 4-digit number. So let's see how easy this is. And just to show you how we can get started here. First of all, here's the dictionary. I'm on CSE right now. Of course, any Unix system will have some sort of a dictionary, probably maybe even several dictionaries. I don't know what's in this folder. Let's check out how many dictionaries are on CSE. Okay, just the American dictionary there. But you can take a look at it, and each line has a dictionary word, right? Bashment, abashless, right? And so you can look through this, and they are in dictionary order because there are some things with capitals and lower cases, etc. And how many words are actually in this dictionary? I'll go ahead and do a word count, number of lines though, in that American dictionary. And there are 307,000 so let's just say 300,000 words in that dictionary. We want to go through there and find the word that I used for my password, with the other condition here that it's a 4-digit number appended. We'll also make the assumption that I started at 1,000. Otherwise, we don't usually go like 0, 1, 2, 3. But of course, you could break it that way too. Use leading zeros in it. All right. Let me go ahead and show you what I've got started so far. And what did I call it? Hack, because we're going to hack my password here. Here's how you would typically use this in PHP. I've got a string that represents my password. And then there's this function that's just sitting out there in the ether called SHA-1. In fact, there's also, you can call MD5 You can call MD4, I believe, as well. You shouldn't, but this is actually why a lot of websites use these blindly use these hashing functions, is because of the ease that you have in, say, PHP. PHP has encouraged a lot of bad habits, and this is one of them, just using a blind hash function like this. Anyway, what I've done is I've hashed the password, and then I print out that the password is mapping to this hash. Let me go ahead and show you this to you in action here. Right? And you see that, like before, password is mapping to this hash. That's the same hash as up here. And it's the same hash as we did it online on that website. Okay? So that's just an example of how you would use it. Let's go ahead and solve this problem. That is, here is the hash that we actually want to break. I'll just go ahead and cut and paste it over here. My hash is equal to there. And does anybody know why we call it hashing functions? All right. So everybody knows hash browns, right? Hash browns. How do you make hash browns? You cut up potatoes, right? That's where we get the hash mark, right? You cut, cut, and then cut, and it's just like hashing. You cut it in several different ways. That's basically what these functions are doing. It's cutting up a domain into discrete codomains, and that's why they call them hash functions. Okay. Anyway, there's my hash. What I need to do is I need to open up this dictionary and process it line by line. For each possible word, I will append a and then for each possible 4-digit number, I will append that. I will hash it, and I'll ask, does this hash map the one that I'm looking for? Okay. So step one, first of all, I've got my hash here. I'll go ahead and get rid of this stuff. Step one would be opening the file and processing it line by line by line. Right? So how do I open a file? I've got a file handle, open, right? And the one that I want to open is specified over here. Right? And I want to open it up for reading. Right? There we go. Now I want to read it line by line by line, right? And so I'm going to have a while loop here. How do I check to see if I'm at the end of the file? FEOF, file, end of file. And while that's not at the end of the file, while it's not the case that I'm at the end of the file, I'll go ahead and read the next line. Okay? So line is equal to, how do I read a line from a file? F gets or forgets, and I'll just simply pass it in that handle. Right? H is short for handle. You can call it F. You can call it my file. You can call it whatever you want. Okay. Yeah. Did we ever determine whether or not forgets retains that end-line character or not? Do you remember in C, with this, those of you with a C background, does forgets retain the end-line character or does not? It retains it. So that's going to mess up our hash because password is not the same thing as password space. So how can we get rid of an end-line character? Word is equal to, we can trim it. Trim the line. Right? That removes all leading space and all trailing space. Yeah?
If we use like get contents,
that's another way. We could use file get contents, and then we'd get this as one big giant string with a bunch of end-line characters. Then we could explode it based on an end-line character, and then we would have an array of of strings, and we could do it that way. Right? The explosion itself would get rid of the end-line characters, right? Because that's your delimiter. Just like the CSV data, when we exploded that based on commas, it got rid of all the commas. Right? So you could do it that way. Or you could, I don't know, do we want to do it that way instead? No? Okay, we've already gone down this road. Let's go ahead and continue, I guess. Once we're done, of course, we should close. Not that it's going to matter because we can't corrupt that file anyway. It's a read-only file. But I've got my word here. Now what I'm going to do is I'm going to hash it. Hash is equal to SHA-1 of the word. Right? And if my hash is equal to that hash. Now, I've not done the 4-digit character yet, right? We're going to hold off on that for a second here. Then I found what I'm looking for, right? So printf found password. What's the password that gave us this? Well, it's that word from that line, right? If we never find it, of course, we can come. We'll get to the end here, and we could, I'll just print a message, done searching, just so that we know that we're actually done and not just sitting there and spinning. Okay. Improvements, before we get to the 4-digit number here, of course this is not going to find anything. Improvements. I particularly want to focus on this line right here. Equals equals. It's kind of safe since this is definitely a string, and these are definitely strings. What's a better way of doing this though? We could go equals equals equals, and now the contents and the type's the same. What's yet another way that we could, an even better way of doing this? C-style way. strcmp, string comparison. Compare that hash with this hash, and if they're equal, here it's pretty safe because it's only ever going to return an integer, but just to be ultra safe, we'll go ahead and go with the strict comparison operator. And if that's 0, then that means that the contents of those two strings are the same, and we output 0. Or then we output that we found the password. Okay? Let's go ahead and run this and see how long it takes. 1, 2, 3. Okay, so less than a little bit noticeable, but we didn't find what we were looking for because my password is not just a dictionary word. It is a dictionary word with a 4-digit number appended to it. So we don't want to just hash this. What do we want to do? We want to go into another loop, right? For I starting at, we'll start it at 0. I plus is less than or equal to, what's the largest 4-digit number? 9999. I plus plus. Here, I plus plus. Mistake already? What happened? I'm still in my C Java head where variables don't have to begin with a $sign. Variables have to begin with a $sign. Otherwise, it'll say, well, that looks like a constant to me, and you never set the constant I, so I don't know what you're talking about. Okay? There. Now I will append word. We'll just say word is equal to word, and now how do I append a string? Dot I, and that's what I'll end up hashing. And I'll move that up here. Yeah, go ahead.
That sounds dangerous because you'd be adding a number to it each time. You wouldn't be getting rid of the number at all. Like people remember. Like if you
Well, the I will change each iteration. This is a string concatenated with a number, which will automatically be converted into a string.
Yes, but you're doing word equals word dot I. The second time you loop around, it'll be the same word.
Good.
0 plus 1.
Good. All right, so help me out.
You want to store the
Appended. I need another variable, right? Appended word. There we go. That'll work. And then I don't hash the word. I hash the appended word. There we go. And then, of course, the appended word. There we go. Everything else is good. All right. Let's run this. I have absolutely no idea how long this will take. But I can do an estimate, right? So let me go ahead and kill this for a second. And again, I have no idea. I haven't tested this at all. Let's go ahead and just go with a counter, right? Is equal to 0. Now, every time I hash something, I will increment that counter. Right? And if the counter hits 1,000,000, if counter is equal to 1,000,000, 1, 2, 3. Let's see how fast this is actually running. Then I'll print out an error message, or not an error message, but a progress message, right? Printf computed 1,000,000 hashes and the line. And then I'll go ahead and reset the counter to 0. So some fixes first of all. Counter with a $, counter, there we go. And we'll see how fast this actually is going. 1, 2, all right, so about 2 seconds for every million. Right? We'll let that run there. And let's go to Wolfram Alpha here. Now remember, there are roughly 300,000 words in that dictionary. And if I go for every 4-digit number, there are 10,000. 1, 2, 3, 0, 0, 0, 0, all the way up to 9999, right? And there's also an issue that I'm not talking about yet that we'll get to in a second here. So that's how many hashes I would end up having to go through. What is that? Maybe Wolfram Alpha will just tell us. That's 3 billion, right? So at 3 billion, and I can do 1 million every second, right? That's 1 million. There we go. So that'll be 3,000 iterations of that print statement, and there are, that's 2 seconds each, so 6,000 seconds, 2 hours. Okay, so it's going to run for about 2 hours, right? Now, this is just on CSE here, and if that's the extent of my security, 2 hours to break a password is nothing, right? But if I were a state actor like the NSA, and we really need to break this password, and I don't have my helpful wrench to hit them over the head with to interview them, then of course I've got supercomputers everywhere. I can go ahead and crack this password very, very quickly. All I need to do is parallelize it. That computer over there will take the first 1,000 words. That computer over there will take the next 1,000 words. Farm it out to 1,000 computers, and we're done really, really quickly. All we have to do is parallelize it. That's something that we'll talk about later on as one of our extra topics. Okay. All right. So that's 2 hours. I'm not going to sit here for it. I think, quite honestly, I don't remember what the password was, but I think that it was appended with like 2019. Because I did it last year. So let's try this again with only one number. Hey, there we go. And you can tell what I was thinking back in 2019. Does anybody know what a maquette is? It's a little small version, yeah, there we go. A maquette is a French word for a scale model, basically. And that's relevant because of Microsoft. So one of my other courses is a VR course, and Microsoft Maquette is this VR experience where you can basically build little kits in a VR space. So if you have a VR headset, go ahead and check it out. I think it's free, but you can basically design models, rudimentary models. Actually, this was cutting edge maybe a year ago. My 7-year-old son is doing this kind of stuff in Roblox, or no, Rec Room. That's it. Rec Room is also VR though, so it's actually pretty cool that you can build these kind of things and animate them without having any 3D modeling experience whatsoever. All right. So that's what I was thinking back then, and we broke out my password. It was just the year, right? And of course, most common passwords are already leaked. You can build these rainbow tables and look them up really quickly. In fact, the best password breaker in the world is Google. If you just simply take a hash and look it up, most likely, if it's already a broken password, you can it'll be there already, right? And Google will pull it up. In fact, there's a website, Am I Pwned or something like that? Am I pwned? There we go. Have I been pwned? Put in your password. Put in your password, and it'll tell you if it appears in any of those databases. Let's see. There are that's 1 million, so 10 billion password accounts have been pwned. I would suggest not putting in a real password. I mean, how do you know that this is not like a farming kind of thing where, okay, we know that they've used that password, and I'm 99% sure whatever you put in this, they're going to hash it, they're going to put it in their database, and now it's definitely been pwned. If you, be careful. But you can see how easy it is to break this kind of stuff if you're using just raw cryptographic kind of stuff like SHA-1. Now, the way that you slow attackers down is by, that I added a 4-digit number. If in your system, you could do the same thing. Basically, you could have, say, we're not going to have a one hash. What we're going to do is we're going to hash it 1,000,000 times, right? Now, for a computer to do that, that'd be pretty quick. But if you have to, if the attacker has to hash it 1,000,000 times for each word, you are slowing them down, right? And slowing them down is the key. And that's what password-based key derivation functions generally do. But then they also add in a salt. Why? Because what do you do with your hash browns? Well, I put ketchup on mine, but what do? You take some salt and you put it on your hash browns. You can also take some pepper and put it on your hash browns. Salts are basically, all right, we've got your password, then we generate a random code and append that, and that's your password. You never actually provide this random code. That random code is stored with the password, but it's a salt. All right, and that defeats all of the rainbow tables, those 10 billion passwords. You just defeated it by putting in a simple randomized string appended to it. Then you can do a pepper, where it's the same one across all passwords. And then you can get really sophisticated and change that salt on every single login. So even if somebody steals one password, the next time you have the same password, the next time you log in, that salt is now changed, and they have to start all over. Right? So, nice little exercise here. Okay. The last thing that I wanted to do with PHP is talk briefly about classes. Most everybody here is coming from either a Java or C background, and both languages support encapsulation. C supports weak encapsulation through structures. Java supports encapsulation, stronger encapsulation through classes. On Thursday, when we start on object-oriented programming in Java, I'll review classes in Java, but I wanted to do that with PHP here to show you what it looks like at least. All right? Classes basically allow you to take multiple pieces of data and put them into one logical unit, right? Just like a structure. A structure that represents a student might have a first name, a last name, an NUID, a GPA, right? So how would you do that in PHP? Well, first of all, you need to be in PHP mode. But you can create a class by declaring a class. And I'm just going to make this public. We'll talk about the visibility keywords in the context of Java. Public just simply means that any of your PHP code can see this class and can create instances of this class. I'll just go ahead and make this a student class that represents a student. Right? Opening curly bracket, closing curly bracket. Now I'm going to put in what are called member variables. These are the things that logically define what a student is, like a last name, a first name, an NUID, and let's say GPA. Note here that I did not say that, again, this is a string, this is a string, this may be a string or an integer for NUID, but I didn't do that. Why? Because we don't have types in PHP, right? I couldn't do something like this, right? So I could theoretically have a last name that was 1, 2, 3, 4, 5. I could have an NUID that was hello, right? It doesn't make much sense, but that's the consequence of having a dynamically typed language, right? If you want something that is statically typed, first of all, go shopping for a better language. But second, there are static typing extensions to PHP, right? So those are member variables. Here I'm going to make them all, you can make them public. The alternative is to make them private, and that's actually the better way of doing it. Private means that nobody can access those variables. So I don't want to save, right? And so what you need to do is you need to allow the outside world access to those variables in, in what are called getters. So for example, if you wanted to allow the outside world access to the last name, public function get name. And what I'll do here is I'll say that this is a formatted name, last name, comma, first name. Right? So I'll return last name appended, appending is, or concatenation is, dot, and then with a comma, space, dot, first name. There we go. Now this isn't going to work, but I'll show you why here in a second. I want to create a student. All right, so could I do, so in Java I would do something like this. New student, and then whatever variables I want to put in there. Well, first of all, is there typing in PHP? No. S is a variable, so therefore it has to begin with a $. And I can do something like this. And I can print f, %s, and the line. Now this is, %s is just a string, and I can go s, I want your name, so get name. Whoa, what's that syntax right there? Arrow, right? Normally, if this were Java, it would be dot, right? But what does dot mean in PHP? Concatenation. So we can't have it mean more than one thing. Instead, we need to use arrow. But you've seen that in C, right? C, you had a structure, a pointer to a structure, meant that you use the indirect component selection operator, the arrow operator. And that's where this comes from, okay? Let's go ahead and try this. Again, I don't think it's going to work. Something's wrong on line 3. Shouldn't be your line 3. What's wrong on line 3? Okay, there is no public. Sorry, there's only public inside the class. All right, there should be something wrong somewhere else on line 11, hopefully. Yay, okay, there's something wrong on line 11. What is it? Last name. So ignore everything else. Only focus on what's in this function right now. Do you see a variable called last name or first name? No. Last name is, we want it to refer to this variable up here. This student's S's first name, S's last name. So we can't use, so what we have to do is we have to say, I want this student's last name, I want this student's first name. And the way that we do that is through a keyword called this. Oops. And then the arrow operator again. Right? Not that we have pointers or anything like that in PHP. That's the selection operator. We don't have the dot operator at all. Dot means concatenation, and it only means concatenation. Okay? Likewise, this is first name. Now wait a second, last name, first name, those are variables, right? So I should have a $sign there as well. Nope. Don't ask me why. The $sign is only at the beginning. Then it knows, okay, well, this is a variable and it's bounded to this student. And so I know that you're talking about variables and, okay, this is last name and first name. And this should work. Yep, it works. What's their first name? What's their last name? Did I say what they were? Nope. So what I need is a way to construct a student, to create a student. In C, what we did is, well, we created a student and then we set their first name, set last name, set whatever, and we realized I don't want to do this over and over and over again, so I will go ahead and create a factory function to do that for me. In Java, they're called constructors, and in PHP, they're also called constructors. So public student, last name, comma, first name, comma, NUID, comma, GPA. There we go. Crossing my fingers here. I don't know that. Yeah, I think this is correct. Otherwise, we'll have to just search for the correct syntax here in a second. But I want to set this student's. You gave me 4 things. You gave me a first name, last name, NUID, and GPA. I want to set this student's data to those 4 values. So all I need to do is this first name is equal to that first name, the first name that you gave me, first name. This last name is equal to the last name that you gave me up here. And we're going out of order, but that's okay. That's just a stylistic thing that I'll fix later. Right? This NUID is equal to that NUID. NUID, there we go. And this GPA is equal to GPA. Right? When I run this, now it's going to complain, hopefully it'll complain. Yep. Ooh, line 10, it's complaining about something I didn't think of. Public, oh, sorry. What does every function have to have? Just like this one. If it's a function, you have to label it as a function. There we go. That's what I was missing, and I knew that there was something wrong. All right. Line 23, exactly 4 expected parameters here. How many did we provide on line 23? None. Right? Okay, so I'll provide Burke, comma, I'll be a student for today. My NUID 1, 2, 3, 4. There we go. And my GPA, should I be generous? Sure. I'll give myself a 4.0. Right. And run this, and we get that behavior right there. Nice. Now I can logically think about this student, that student, etc. One thing about PHP that will also translate over into Java, remember that if I want I actually have to go and get a formatted name. What if I just wanted to print the object itself? In other words, print S. What will this end up printing? Recoverable fatal error. I've never seen that one before. Object of class student cannot be converted to a string. Right? So did I specify up here what the string representation of this thing is? I created a function called getName that formatted it last name, comma, first name. But otherwise in Java, how would you end up going about doing this? You'd create a ToString method. In C, you would have created a student ToString function, and then you gave it a student structure instance, and then it gave you a string back, right? In this case, though, we'd also create a ToString function, but it has this very special syntax. Public function, because it's still a function, underscore underscore ToString. And remember that it is case insensitive everywhere, so this would be valid, but it'd be very bad style. So I'll go ahead and go with this, ToString. What is this underscore underscore? That's a very special type of syntax in PHP that designates this function is a magic function. Magic functions are ones that are built into the language, that any class should have a ToString method. Now, obviously, that's not the case here with newer PHP, but there are, I think that the list of magic functions, PHP magic functions, what is the list of magic functions? Magic methods, sorry. If it belongs to a class, it's called a method, right? Constructors, destructors, clone, serialize, ToString, unset if you wanted to delete it from memory. And so we're going to focus here on ToString here. And all this does is returns a string representation of this thing. And all I'm going to do here is I'm going to call getName. Right? This instance's getName function, and it'll return that string right here. And so now this should work just as before, Bert, comma, Chris, but there's something wrong in line 29, which is, oh, come on, ToString. Must return a string value on line 29. Yeah, it's right there. Okay, let's check it out. ToString. ToString. All right, why are you complaining? Oh, thank you. And here I was about to erase everything and start over. Thank you. It doesn't have a return statement. It's not returning anything. This has no effect. Okay, fine. Here's your string. You do nothing with it. You don't capture it into a variable. You don't return it. That's the proper way. There we go. There, Bert, comma, Chris. Let me add. I could add an end line character if we wanted to, but that's fine. All right. Let's create one more student over here. Oops. Smith, Joe, and 6, 8, and give them a 2.0, bad student. And then I need S1, and 2, and let's do one more student here. Come on. S3 is a new student, Apple, Jane Apple, and 1, 2, 1, 2, 3.0. All right. Now let's go ahead and put all of them into an array. So roster, say, is equal to an array containing S1, S2, and S3. And let's pretty print that. Print R roster. And I think that this will end up calling the ToString method on each one of them. And so, oh no, it won't. It'll actually print out like the last name, student, private, Apple, Jane, et cetera, et cetera, et cetera. Right? But you can see that the order here is Burke, then Smith, then Apple. That's the order that I put them in. What if I wanted to sort them according to last name, first name? Can I do something like this? Sort roster. And instead of pretty printing, that's not very pretty. So let's just go ahead and go into a for loop for each student in, or sorry, that's the Python speaking, for each, what is it, roster as S. It's not a map because we don't, I mean, you could treat it like a map if you really wanted to, but this is just a straight up array, zero indexed. So I can use this syntax instead. Before we had as key mapping to a value. Right? You could still do that. It's just that the keys would end up being 0, 1, and 2. Who cares, right? As S. I'll print S and the line. No need to get fancy here. There. Oops. All right. Clear that. As it should work. For each roster. Okay, there we go. It was just screwing up. I just had to clear it out. I don't know why it was doing that. But anyway, you see the original order. Oh, no, you don't see the original. Oh, you know what? Sort. It worked, but I don't think it worked because. Why did you work? one of the great mysteries of PHP. I don't know why it worked on this one. I imagine that the default behavior is that it's getting that last name, and then the first name. So let's go ahead and do one more student here, and what we'll do is we'll make it into another Apple, S4, but that should come before Jane, Allison. All right, there we go, and 3. And then we'll put her last, but she should come first, right? Let's find out. Huh, really? All right, it's probably just going down the list here. I wonder what would happen if we change this so that it's first name, last name. Now will it sort in first name, last name? This is my guess, right? No, it does not. Oh, no, it does. Allison, then Chris, then Jane, then Joe. So it looks like it's just going down the list here. And if I had put GPA first up here instead, I imagine that it'll be the worst students first. So Smith, yep, because he's got a 2, and it's in ascending order. And then Apple and Apple 3.0, we'll give her a 3.5 so that Allison comes in second, definitely, third, sorry. And then me with my 4.0 average down here. That's the default behavior. The order matters up here. Okay, that doesn't make that much sense to me, but so be it. What's an alternative? Oh, do we want to? I'll go ahead and keep it like this. Because if I were designing the object, I'd say, okay, first name, middle name, last name. That's natural, right? But then when we sort it, of course, that's not what I'm getting. Those 2 apples should be up at the top. Okay? So how do we go about sorting it properly? If I want to customize my sort, do you remember from last time? Sort is a natural sort. Usort, you provide a comparator as a function. And remember that there are all these other variations where you can sort by keys, you can sort by values, et cetera, et cetera. The one that we want is usort, where it's completely user defined, okay? All by value. So what I need is a function. Function, CMP student by name, okay? And by the way, I can't simply just use this get name right here because the comma would come into play. Apples, or if somebody had the last name Apples, right, an apple, the comma would end up coming first. That would actually work in that case. So, but it's not going to. I'm sure that we could come up with a degenerate case where it wouldn't work, right? So, I'm going to create a function to do this for me. Compare student by name. We'll take the student A and the student B. And then I will compare them by their last names. So I'll take a result here, and this is usually how we've done it. strcmp. I will take A's last name and B's last name, and I will compare them. Now if that's 0, they have the same last name, Apple and Apple, then to break that tie, I have to go to their first name. So if the result is 0, and I will be strict on it, right, then I need to look at their first name. Now, if their last name and their first name are exactly the same, then how do I break ties? You could go to NUID or something else like that. Who cares? First name, and first name. There we go. And then I will return result. Note here, I'm just reusing strcmp because it already has that contract. It returns something negative if they're in order, positive if they're out of order, and 0 if they're equal. Now, I need to pass this into usort. I'm going to sort the roster, and I pass in a function by using a string of its name. Okay? And yeah. Oh, thank you. First name, thank you. First name. Still not going to work because there's something wrong, but we'll find out what that wrong thing is here in a second. We see it. Uncaught error. Cannot access private property of the first student or the second student. All right? Let's go back up to our design here. Private means that only the class can see it. Right? This is my private data, right? Now, when we did provide the inputs here as at the constructor when we created this student, but these lines here took those values and then put them into these private variables over here. I'm not allowing you access to these things. Now, the alternative would be to make all of these things public, right? Public, public, public. And now this will run, I assume. Oh, sorry, did I misspell result? Got the $. And are we good now? Yeah, there we go. And there, Apple, Allison comes first. Apple, Jane comes next. Then me, then Joe. Yeah, go ahead. Static is for when it usually, if you make a variable static, PHP does have static variables. That means that not every student would have the same first name. By doing it like this, now every student has the same first name, right? Because that variable belongs to the class, not to instances of the class. And so if you have like a public static void main, right, in Java, you only have one main function. If you have student A and student B, they don't have their own main functions, right? They have the same main function. And so you would use static if you want it to belong to the class, not to instances of the class. Same thing with PHP, the same meaning for that static keyword. Of course, I want everybody to have their own unique first name, possibly unique first name. And so I'm going to make it non-static. But it is actually really bad practice to make variables public. Right? You generally want to make class variables, member variables, still don't want to save it, as private. Right? and control access to them through what are called getters and setters. So for example, we do want access to the first name and the last name here. So let me make public functions for get first name. And let me make a public function for get last name. Return this first name. And I'm not going to do GPA or NUID because it's the same basic idea, same syntax, but first name, last name. This is all we're going to need. Now, instead of getting that variable directly, I will call the getter function, get first name. And that is a function, so you need it like that. There we go. A's first name. I'm running out of real estate here. But get last name, and that is a function just like that. So there we go. This should run unless I made a mistake. Good. But now I'm getting basically a copy of that variable because it's returning that string, a copy of that string. Right? So I'm not able to jump into the student object and start mucking with its data. Right? What if I did? What if I wanted, that's not, here, the traditional Burke spelling instead of my spelling. That's not what I meant. I want to change my last name to the correct spelling of B-O-U-R-K-E, or at least my spelling of it, right? S1 last name is equal to the correct spelling. Of course, this is not going to work because it is private. So how can I allow somebody to change variables? What's the opposite of a getter? Setter. So public function set last name. And you do take input here, what the new last name that you want to use. Last name. And then this last name is equal to the given last name. And this seems, keep saving out of habit here, sorry. So I'll set last name. And instead of using the assignment of, operator there, I will go ahead and pass it in as a function. And now you can see that it'll actually run, and there's the correct spelling of my name. If I didn't have this, of course, I would have that old incorrect spelling, B-U-R-K, okay? And that seems like a good idea. Well, two initial impressions that people have when they see something like this. The first initial impression is, man, why do I have to write so much code to have a bunch of getters and setters when I could just make them public and I don't have to write that code at all? Fair argument. Counter argument, don't write that code. Let your IDE do it for you. Your integrated development environment can generate code, and I'll show you how to do that in Eclipse when we look at this again in Java. Second argument is you want everything to be private, right? Because you want to control access to it, especially in a language like PHP. Remember, I said that my first name could be 1234, an integer, or my first name is 3.5. There's nothing to prevent that. 3.5. Right? And now I'm a Chris 3.5 instead of Chris Burke. Right? A neat, not a neat story about a department. I think like 10 or 15 years ago, there was a guy in a department, he still teaches at, I think, Hope College, Charles Cusack. He had a twin brother, I don't forget the twin brother's name, but they made national headlines because they named their kid whatever his, instead of Joe Cusack Jr., they named him Joe, officially on his birth certificate, Joe Cusack 2.0. So you can have names that are numbers, I suppose, but it depends on how, you know, how loose you are with those kinds of things. Yeah. What's Elon Musk's kid's name?
It was like Kyle, but it was spelled with like, you know how...
Oh, like leet speak and stuff, like K4LY or you know, yeah, whatever.
I don't know if that's true.
I have no idea either. But in any case, a setter and a getter, or a setter at least, allows you more control over that. So for example, if the last name that they're trying to set this to is empty, right? That's bad data. Or if the last name type of last name is equal, I'm going to have to remember my type of. How do I determine the type of a variable in PHP? Come on, get type, sorry. And that should return a string, I believe. Get type, yep, it returns a string, and those are the acceptable values. So if it's not a string, then I can reject that, right? So if the, get type of is not equal to a string, then I can say that that's bad data. I could throw an exception. Throw exception. You must provide a non-empty string as a last name. I'm really running out of real estate now. Let's try this. It should still work because I changed it back to Burke. But if I provide Burke or Chris 3.5, then I can throw that back at you and say, no, you can't do that. And in a dynamically typed language like PHP, this starts to become a necessity if you really want to enforce type safety and if you really want to enforce these rules. Especially if you don't want this kind of garbage getting into your database and free form data, anybody can mash the keyboard. You need a whole bunch of data validation. And you can see how that would turn into a big mess pretty quick. Well, it can be an integer or it can be a string, but it can't be a floating point number, right? Or I want behavior, so if here's a function that I've designed and here's the input. If the input is a string, do one thing. If the input is an integer, then do a different thing, right? You have these big giant if-else-if conditions or switch cases or whatever, and it gets really, really daunting really, really quickly, right? So hopefully that's an argument that hold your horses if you thought that dynamic typing was a great thing. It has a lot of implications, right? It has a lot of potentially bad things, right? I'll go ahead and change this back to Burke so that it doesn't throw that exception. But generally, setters allow you to control what people can set it to. Or for example, if it's null, right? If that, I could reject that as well and say, no, you can't set a last name to null. I don't allow that. Right? Yeah?
Do we have to add all this to our stuff for assignment 1?
So the question is, do we have to do this for assignment 1? The answer is you can do assignment 1 however you want, right? So, but in assignment 1, where could you use a class?
Or no, not a class. I mean, but like check the type.
Oh, the type checking. No, generally you don't. We're going to give you good input.
Okay.
Now, for the BSA, I think that we could give you like bad input, like they weigh negative 50 pounds. And you certainly should check for something like that. But typing, no, because command line arguments, those are always strings. And you make an assumption that that's going to be an integer, and you convert it to an integer, well, then that's on them if they didn't put in good data. Right?
Okay. Cool.
But I thought that the question would be, do we have to use a class? And absolutely not, you don't have to. But I'm sure that it would be really, really helpful. Why? Maybe, maybe not. I don't know. It depends on your perspective. What in your first assignment could you make a class out of? Or for? A game? Okay. Yeah. Why? Because a game has a title, a publisher, a published year, I think, maybe, I forget, and a list of consoles that it may be on. And it may not be available on any consoles. And if that's the case, then that would be an empty array. Right? And so that's one way that you could represent your game, right? By creating a class and then updating it. Of course, you don't have to do it that way, but that's one way of doing it. I'll go ahead and cut and paste this and make sure that it's in the notes for you. PHP, there we go. There, right? So basic creation of a class. ToString and constructor. I think that this is actually going to be an alias to a constructor. If we look back at these magic methods, this is the proper way of doing it. So proper way of doing it. I'll do it like this. Construct All right, there we go. And that's how you should do it. It's a magic method. I think it's forgiving me because it's a 7.0 and you can do it like that now. If you use old school PHP, you may not be able to do it how I did before. All right? No questions online? Any questions so far? No? We've got 20 minutes left. That's the end of PHP that I wanted to show. The other PHP I would show you is PHP sadness.com. Is it? It should still be up. I think that this website was put together by the same guy that does the Advent of Code each year. And basically, it's Eric Wassel on Twitter. So he's maintained this list of really, really bad things about PHP. And it gets updated because the language does get updated, and sometimes these things are addressed, but it's always had a bad reputation as a language. Right? More so than other languages. Like there's some bad language. JavaScript is typically a bad language for a lot of the same reasons that PHP is, but here are some complaints. If you go to PHP sadness, and he's got a very, very nice prose style where he, complains about the language over and over. Yeah.
Does strcpy or string copy work in PHP?
The strcpy is not necessary because it's a dynamic language. If you want to copy one string to another, just do it, right? You could just set a string. A is equal to hello. B is equal to A, right? Print A, print B. And you can see that they're the same thing. Hello and hello. Let's print these nicely. One to a line, right? Now, if I make a change to 1, this is a good question. If I change A, its first character, I can change that to a lowercase h. So if this prints out 2 different strings, what does that tell you about this kind of assignment right here? It's a deep copy. If it prints out the same thing, both lowercase h's, then you know that it's a shallow copy. Let's find out which one it is. It is a deep copy. So if I'm going to, there's no reason to do strcpy because the assignment operator is already a deep copy. You can do a shallow copy if you really care about it. C is equal to A. Now let's change A to be, I don't know, capital A. And let's print out both A and C. I think that this should work. So I changed it to A. This should print out A yellow, A yellow, A yellow, A yellow. Why is this a shallow copy? That ampersand in front is basically coming from C, where you get the memory address, right? And that's what that's doing. Just like we saw this before when we pass an array by reference. To get it to do it by reference, it's an ampersand in front of it. Technically, there are no pointers in PHP, but there are ways of doing references, rudimentary references like this.
So that's why you wouldn't put an ampersand in front of C as well?
Correct, because you don't have any pointers. Right? In C, you'd have to do int star C is equal to that, but there are no types. So, right? I'm sure that if we go unset C, that is we're actually deleting the variable. Let's see what happens with A. Of course, printing out C would be wrong. This will probably result in an error because C is no longer defined at that point. But what happens if I print out A, which was a shallow copy, or C was a shallow copy. We deleted the shallow copy. We'll probably end up, oh, no, it's still alive. Okay. What if we unset A, get the same thing? Now if we try to print C, it's still alive. So even though we unset it, we deleted it, something else was still referencing it, so I guess it refused to delete it. Don't ask me. That's not what I expected. But again, that would fall under the heading of PHP sadness. Counterintuitive things, function naming, prefixes, underscores, the fact that functions are case insensitive. What? Comparison operators are all over. There's actually a codeless code post about comparison operators, and basically you can get, if you do it right, I mean, this is not something you do in normal code, but you can get it right so that you can make things so that normally if A is equal to B and B is equal to C, the transitive property would say that A is equal to C. In PHP, it doesn't work like that. You can come up with an A and a B and a C such that A is equal to B and B is equal to C, but A is not equal to C. So there are that's the basic idea. There are inconsistencies that you can get in the language by doing that kind of stuff. And that's what you get when some guy in his basement put together a language just because he wanted a nice counter on his web page. It became popular enough that it would not die, and people have just thrown things in ad hoc over the years, held together with duct tape.
I guess you could say it's because someone keeps referencing it.
Well, I think to this day, something like 30% or maybe more websites run on PHP. Content management systems run on PHP everywhere, like Drupal, if you've ever heard of that. Our website, CSE's, or UNL's websites run on some CMS, I think it's Drupal. That's backed by PHP. Facebook is written in PHP. It will never die. So it's here to stay, warts and all. No questions online? All right, then what we'll do on Thursday when we come back is switch gears a little bit, talk about object-oriented programming like we just did, but we will do it in the context of Java. All right, see you then.